mitigasi hal yang tersebut. Nah, langsung saja. Hi Lars, how are you today?
Hello, Adi. Hello, everyone. I'm doing fine. Thank
Hello,
you.
Lars.
Hello.
Hello.
Hello, can you hear me? The sound is okay?
Nice to see you again.
Nice to see you again.
Okay,
Thank you. Thank you for the
Lars,
invite.
thank you
Yes.
very much. So I think it will be a fruitful knowledge on this session. So on the further 1 hour, I hope you can share your knowledge and to the attendee over here.
Thank you very much, Adi. Thank you to you and to PT Tiara for the invitation. And I will try to keep everything today within satu jam, 1 hour. Did I say that correctly? So if I can start, if you give me the go ahead, please, and let me know if you can clearly see my screen, and I will start my
Yes,
presentation. All clear?
yes, all
Okay,
clear.
good. Thank you very much. Thank you, Pagadi. Thank you, PT Tiara, and the colleagues there. Today, I have the honor to share with you, our beloved audience and customers, about the silent threat to your machinery and understanding and mitigating this thing called lubricant varnish. So we have a lot of knowledge to go through in 1 hour. So sometimes I go a little bit quickly, I know that, but I have to in order to make sure that I cover everything. So please feel free to write down your questions in the chat, and we will do our best to get to them later. If we cannot address them today, then I'm sure we will reach out to you and make sure that your questions get answered. So we don't want to leave you with any questions today. We want to make sure that everything is answered. Okay, so let's get started. You can already see a little bit of a picture here of a bearing from a turbine. One is relatively clean and the other one has a varnish problem. How does that happen? That's the biggest question that we want to get answered today. And more importantly, even, what can we do about it? So let's go back to the beginning a little bit. Let's look at the importance of lubrication. Why is this such an area of interest for us, for PT Tiara and a company like FLUITEC? We have built our whole business around lubrication. And now I'm showing you a very old picture of an Egyptian. And you might think, why is this a webinar about history? No, it is not. This is a webinar about lubrication. And I will share with you why. Because what we are looking at here might be a very smart fellow, a very smart person here, that could be the first lubrication expert in the history of humanity. Because what this person here has figured out, that if he pours the water onto the floor in front of the sled that they are trying to pull, the soil gets looser, and that reduces the coefficient of friction.
Oh,
By reducing the friction, it makes it easier to move the sled. So he might be the world's very first lubrication expert. But when we move forward to more recent times, there has been a lot of reporting from industry specialists and reporting agencies that there is a lot of money to be made in the industry by improving efficiency of lubrication. And they called it here, they started to call it in 1966 its own science, tribology, the science of tribology, which means the science of relative of surfaces in relative motion to each other, and also including lubrication, friction, and wear. That is what tribology stands for. So this term was coined in 1966, and this is what we still use today. In 1982, for example, a research in Canada found that there could be 5 billion saved across 7 industrial sectors if people would pay more attention to lubrication. So this science of lubrication has a multi-billion-dollar impact on the global economy and has a lot of potential to save money for the end users. And today we will dive into a little bit how. So how can this lubrication thing, this verbology, actually save you some money? Well, first of all, it can help you to prevent catastrophic failures. Now, what I'm showing you now is an extreme case, of course, where we have a coal-fired power plant in South Africa. Due to improper lubrication, the valves stuck and the system was able to run away. The overspeed trip assembly was not functioning anymore. And this led to a runaway turbine, which then eventually exploded. So you can see here the bullet holes, so to speak, the shrapnel going through the roof, and here the parts that were flying around. And the company officially said, oh, this was just a routine test and we were planning to destroy it, but it was not. And the employees of this company were unhappy, and they posted to the press this what really happened, right? So they went behind the backs of their boss and said, no, that's not true. This was a failure, and due to improper attention to the lubrication. Of course, this is an extreme example, but also in smaller turbines, this is in a university campus in the US that had their own power gen. You can see that they were doing a very old-fashioned kind of lubrication monitoring. They were only looking at viscosity and acid number, which is a very traditional, very old way of monitoring turbine oil. But it doesn't cover everything. It cannot allow you to be predictive. So what happened, suddenly there was an issue that went undetected. There was a leak that coolant was mixing with the turbine oil that led to high oxidation and acid increase, which suddenly increased the viscosity of the oil. That led to an immediate failure of this turbine. And you can see also in the filter examination, clearly there was a lot of stuff in there that should not be there, and the filters were completely plugged. When we analyzed this, we could clearly see that this was oxidized oil as a result from a coolant leak. But by then, it was too late to save the turbine. Of course, the damage was done. And this company is now one of the best customers of FLUITEC because they never want this to happen again. So another way of looking at this is when we look actually a bit from the environmental aspect. When we consider lubricants as a bad industry for the environment, that's logical, right? It's a brown industry. It takes a lot of energy and a lot of pollution to produce lubricants. But when we look at the scale of lubricant production here versus the energy that gets lost in friction, you can see that the energy that gets lost in friction is many, many times more than what it actually costs to produce lubricants. So even if we would reduce the friction by a few percent, we can save so much energy. That means if you're a power plant or even anything that uses a lot of moving parts, by reducing friction, you reduce your energy expense enormously. Now, of course, we live in a world today where the energy prices are going up and up. So this becomes even more impactful. So by increasing the efficiency of your lubrication, you reduce friction, you increase your efficiency, you reduce your energy spending. Good for the environment and good for your bottom line. So you save money while you're also helping to save the environment. So let's look a little bit deeper into rotary equipment, turbines and compressors. Later we talk a little bit about hydraulic. I will go over this fairly quickly because I think people that operate this, they will be very well aware, but just to have an overview, these are the typical types of rotary equipment with varnish issues, such as gas turbines, the generators, the synchronized shift, self-synchronizing shifter, steam turbines, auxiliary systems like oil tanks and pumps, and gearboxes. So just a little bit to give you an idea, this is a Siemens Energy gas turbine 4000F, SGT5 4000F, which is a very commonly used product here at PowerGen. We are treating one of these in Singapore, huge turbines, 40,000 liters of oil, so big systems. And the critical loop areas would be in the bearings and in the inlet guide vanes, because they are operated by valves. And if these valves start sticking because of improper lubrication, then we can run into issues. This is an example of a steam turbine, in this case a nuclear steam turbine, huge unit, this one an SST 9000. You have a high pressure turbine and low pressure turbines. Critical areas where a lot of oil runs through are the bearing systems here as well. They can have varnish, which increase their temperature and lead to a lot of issues. Let's look at a typical PowerGen oil module. So this is a big engineering part of the turbine, because sometimes you think an oil tank is just a tank, but actually it comes with a lot of complicated systems and redundancy. For example, you have two full capacity AC lube oil pumps, and for when there is a failure in power, a direct current emergency oil pump. 2 full capacity redundant oil filters, 2 full capacity, fully redundant oil coolers. So when one fails, there's full redundancy. So this shows you how much emphasis the OEMs put on proper lubrication and on the oil system. You can also see this from this diagram here. The red pipes in this system indicate everything that's a part of the oil system. Huge engineering item, and also a lot of areas where the oil has to flow through and where it can encounter stressors and a lot of other things that could impact its performance. So it's an enormous engineering part of power gen turbines, for example. Now let's look a little bit at how these oils can degrade and what the problem of varnish can be in these systems. I don't know if you guys can see this yellow line where they are appearing on my screen, but okay, I'll try to work around it. So this is an animation where you can see the turbine gets opened up, and we can see a little bit about how the oil system works, right? So this is a typical power gen gas turbine package. And this is the oil tank that in this case has some submerged heater, which is not always the case in turbines. But when there is an oil wetted heater system, this can of course be impacted by varnish. So sometimes the oil needs to be heated before starting the turbine. That can be a reason to have this kind of system in place. So, sorry, this is an interactive part of one of the training modules that we have now developed. So I would also encourage you to have a look at those. Let me see if this is the... Yes, okay. So now we can look at exploring how does varnish originate. You can see here, these are depiction of hydrocarbon molecules, so oil molecules flowing into the turbine system, nicely clean. But let's look at what is happening to this molecule when it flows through the system. Now it is starting to be interacted with or being affected by stressors. So those can be heat, oxygen, things like water, also wear metals in your system. They are all impacting this oil molecule. And you can see that it's suffering, it's starting to degrade. It loses a little bit of its composure, and it might even become a charged particle. So that is the initiation. And what happens then? It produces something called a free radical. That is a molecule that is very interactive, doesn't have a purpose. Now we have this free radical, and there are 2 things that can happen to this free radical. Let's see what can happen to it. When we go for what we call the first option, path A, is that we have an antioxidant in the system. So the crystal ball here is the antioxidant, and it starts to neutralize these free radicals, because that is what an antioxidant is supposed to do. It is going to protect the oil from these free radicals. But the more it does that, the more it reduces in power. So the more free radicals you have, the more antioxidants will be consumed. So your antioxidant level will get lower and lower and lower, right? So then when you do not have any more antioxidants, you start to propagate the free radical. That means these molecules that are being attacked by free radicals are no longer protected by antioxidants. So these free radicals can reproduce and can attack other molecules. And that is how we will really start to degrade the oil. That is why we call it propagation, because this problem will get bigger and bigger, and your oil will start to degrade from this point onwards. So it's very important to keep a good eye on the additive level, primarily the antioxidants in your oil. So let's see here what happens when we have varnish in the system. So for example, you can see this in oil coolers or heat transfer systems. You can visually see varnish in your oil system occurring after this has happened. But also in hot areas of the turbine, that is what we call hot varnish, where the oil film is operating under high pressure and high load, and the actual oil film is very, very thin. that is where we what we call shear stress. There is shear stress on the oil. So that happens in, for example, journal bearings or truss bearings, which you can see depicted here. And there's only a very thin layer of oil, even if you have 40,000 liters of oil in your system. Right here in this bearing, the oil layer is very thin and it's exposed to a lot of heat and a lot of stress. So when you have varnish in your system and it goes into the bearing or into the truss bearing, it will create localized hotspots and deposits. But also, there could be in the oil film itself, in the bearing, there could be a hotspot that is increasing the varnish buildup locally. That is what we call shear stress deposit. So you will hear a little bit more about that later. So there you have a hotspot and a buildup of varnish here in this bearing. And that is the picture that I showed all the way in the beginning at the starting page of the presentation. Is a perfect example of what is happening here. The hotspot is leading to localized varnish buildup in the high load zone, and that is leading to deposits and shear stress deposits, as we call them, otherwise known in the industry as hot varnish. Sorry, I need to. Yes, okay. So we figured out that here in the oil film, the hotspot can go above 200 degrees C in the oil layer, and that can really degrade the additives of the oil. This has been supported by research with OEMs, so we can share that with you as well in the future. But let's see what's happening to the bearing once you have this varnish incurring. So what you can see, the bearing is lubricated by an oil wedge. I know the positioning of the shaft is not entirely accurate here. I do apologize. We need to update these animations, but for now it works to explain this to you. So here you have the varnish building up, as you can see indicated, and that increases your temperature. The temperature will go up as well, but the varnish will suddenly be wiped off. And we are depicting here that wipe off event. Let me play it again. So what is very telling when you have varnish in your bearing is this symptom here. This is where you need to pay attention, because when you have these temperature fluctuations in bearings, that means you likely have deposit or varnish in your bearing. So you can measure that not only by oil analysis, but by looking at the temperature. Look at how this temperature fluctuates. It goes up, suddenly it goes down. We call that a sawtooth pattern. So when you encounter this in your bearings, it is most likely due to varnish and deposits. Varnish is an oil-derived deposit, so it's not an external contaminant. It's coming from inside your oil, from the oil degradation, and it's very difficult to wipe varnish. So let's look a little bit at the different kinds of varnish that we encounter. So, for example, sludge is usually some oxidation plus moisture, very sticky, sludgy. That's why it's called sludge material that is easy to wipe or to manipulate. It gets clogged into your filters or into your piping system, for example, as you can see here. The difference between sludge and varnish is actually the same origin, the same cause, but the difference is sludge is wipeable and varnish is not. So here we see varnish as an example in the oil tank, historical deposits, and you can see this technician cannot wipe it, nothing sticks to his finger. And that is when we make the distinction between sludge and varnish. But both are coming from oil degradation. When we increase the temperature, that is where we go to the hot zones of the equipment, in this case, the truss bearing. So remember the animation that I just showed you? This is where these kind of varnish will settle, and that is what we call hot varnish or shear stress deposits that will affect your bearing system. In the much higher spectrum of temperatures, you can get coking or pyrolysis, but this is really rare to see, but just for completion, we put it in. It can have a lot of different appearances. It's not just one brownish substance. Sometimes we have jelly or coking in the filter that we encounter, which are actually also forms of varnish. It can come in a lot of different colors as well. So it's not just one type of degradation. There's many complicated origins that can cause varnish in your system. What's also important to think about is varnish is soluble. So at room temperature, you can clearly see there's something wrong with this oil. But when I start to increase the temperature to about 50 degrees C, which is the normal operating temperature, suddenly the varnish dissolves. And when I put some turbulence into it, the varnish dissolves even quicker. These are the exact operating conditions in your equipment. So this is why you cannot filter out varnish, because once it's in operating conditions, it will pass through your filter membranes, and it's almost impossible to remove unless you use specialized solutions, which we will talk a little bit more about later. So let's look at why is this such a big issue today? What is the origin of that? And that is actually a multifactorial thing, because it has something to do with the application side. So that is the OEM that is always pushed to design higher efficient turbines, higher thermal loads, higher power outputs, and so on, which finds its way into the design of the oil system, the design of the bearings, the valves, and all of that. Everything is always designed to be more efficient. The oil volume tends to become smaller because they want to use less oil for a varied amount of reasons. And on the other side, we have something to do. It has something to do with the oil. The formulation of the oil, the actual chemistry that goes into the oil, has changed. There's different kinds of base stocks, different kinds of additive chemistry that is combined with the operating conditions that the OEM has now designed. That is basically creating a lot of varnish at the moment. So it's a huge issue. Let's summarize a little bit about the two main failure modes that we have distinguished so far in turbine oil, so rotary equipment, for example, but this also applies to hydraulics. It's the same method of degradation that we see in hydraulics that we can also treat with our products. So, for example, the main thing is oxidation. Everything oxidizes when you increase temperature. It doubles in oxidation. By 10 degrees temperature, the rate of oxidation doubles. Another thing that we've looked at already is shear stress. So on the hot zones of your equipment, shearing stress can increase the temperature of the oil film, which then leads to deposits and varnish. Or the varnish that is already in your system tends to settle out in the hot zones of your equipment, which are also the most critical zones. So this is a huge issue. So what kind of impacts will this have on your equipment and on your components? First of all, the lube oil reservoir, like we have just shown also in the picture, you can clearly see the bathtub ring, and it's not easy to wipe that. That can be the first indication of varnish in many cases. But the biggest issue that we see operationally are valve sticking or blocked orifices to the valves, which reduce or even completely block the oil flow. That leads to massive issues. That is also the case that we saw with the exploding turbine in the beginning. That is a perfect case of valve sticking. The second most common problem with varnish is bearing instability. Remember the temperature graph that I showed you, the sawtooth temperatures? That is bearing instability. It will also correlate with vibration. A huge issue at the moment for turbine users and rotary equipment. Seals, when you have deposits in your oil, some oils are acting as a sealant, but also the degrading chemistry of the oil can impact the seal integrity. So you will get leakage of seals, for example, due to oil degradation. And what we have seen also in the animations earlier is cooler or heater efficiency. When they are coated with a layer of deposits, they become insulated and they reduce in efficiency. So very often we visit plants that say, oh, my startup time increased a lot because my plant is old. And then we start to treat the varnish and remove it from the system. And suddenly the startup time reduces back to when the plant was new. And the operator thought this was not possible because they thought it was just wear and tear of the heater, but it was actually a varnish problem. So when we remove the varnish, the startup times reduce back to new. This is an example of valve sticking, and you can see if you imagine this, that even a very small amount of varnish and deposits that are sticky on this valve can block it and can prevent it from doing its work. Here, we've already seen this, but heaters and coolers, when you got this insulating layer on them, they reduce in efficiency. And very important nowadays, wear rates on the bearings. These are all examples of shear stress deposits where the hotspot in the bearing created localized deposits and reduced the ability of the bearing to lubricate and cool, which leads then to bearing instability and eventually will lead to a failure. Truss bearings, the same thing. You can see here on the most left picture, you can see that there has been wear. So that means removal of metal. This is due to fatigue wear, due to constant metal-to-metal contact, slowly pitting out metal of the bearing, and this will increase the wear metals in your system and will eventually lead to a total bearing failure. So again, to highlight the sawtooth pattern, this is the easiest way to detect shear stress deposits. Of course, oil analysis will show you a lot of your oil health, but sometimes it doesn't pick up small amounts of deposits that are in your bearing already. But then you will see the sawtooth pattern happening. Now, this is a extreme case where the temperature spikes went up a lot eventually, but we would want to act more in the beginning of this graph where the temperature excursions are still quite small. But we know when you have this kind of pattern, we know that it is shear stress deposits. So we can already act quite early. Now let's look a little bit at rotary equipment, but what about hydraulic systems? And let's look also a little bit at the additive system of the oil, the chemistry of the oil, because there is such a thing that we call fill for life or perform for life, which are linked to each other. That means that we can replenish or replace the additives in your oil to prevent oxidation. So modern hydraulic systems, for example, they fail mainly for two ways at once. So that is, one is generation of deposits, so oxidation related, right? The other one is because the additives are depleting. And that means that, for example, in hydraulic, you have sometimes zinc or complex antioxidants, which then reduce the anti-wear capacity of the hydraulic. That leads to high wear and tear of the equipment. So it's deposits and oxidation and additive depletion. And in hydraulic, we also have the same problem that we see in turbines. The power intensity went up. That means the equipment needs to be more efficient, whilst the oil volume is going down. So that means more stress on the oil. That means the bigger problems with oil systems. So when varnish shows up in hydraulics, you can get things like valve stiction, loss of heat transfer of the oil, and wear an internal degradation of your system, of your equipment, because the additive system is no longer able to protect. So for example, in injection molding, you can get shot-to-shot variation, which means that maybe you have to scrap a whole batch of material because the production was not accurate enough. That can be due to valve stiction, for example. Of course, higher scrap leads to lower yield and more frequent, longer taking mold changes. Right? Presses and stamping, you could get a line-wide downtime just from one little valve stiction, and we see this a lot. So this is a big issue, and it's so easy to solve because it's just due to a little bit of varnish in the system. But it happens. The whole line will be shut down because of a minor deposit issue. In steel, you can have a quality downgrade and breakout risk because of the degradation of the gauge control. Mold oscillation and instability can happen as well, for example. And in pulp and paper, you can get off-spec reel and hours per break, for example. So pulp and paper is an area where you see huge oil volumes and a lot of emphasis on heat transfer as well. And that can be highly impacted by varnish. We have a lot of success cases in all of these industries to prevent varnish. Okay, so that is in rotary equipment and hydraulics, the problems that we see with varnish. But today we would also like to talk a little bit about solutions. We want to give you something to solve this issue. Now, when we talk about solutions, we first need to talk a little bit about testing, because we need to perform the right tests on the oil, especially in rotary equipment. In hydraulics, this is maybe less common, and you can look at operating conditions such as clamping speed, accuracy of your injection mold, valve sticking, and so on. That's for hydraulics, the main mode of looking at it. But when you have big oil sums, a huge power gen turbine, usually you will have some form of oil analysis program, and you will test your oil hopefully regularly. So the tests that we would recommend to prevent varnish are actually two main tests. The most obvious and easiest one to do is the MPC test. So our partner PT Tiara can help you with setting this up. The MPC test under ASTM D7843 is now the most used test to look at the varnish potential of the oil. And I'll show you how it works. Another test that's very important is to look at the additives of your oil. You can do that by doing a destructive test on the oil, which is the RPVOT, that oxidizes the oil to failure. But that's a pretty difficult test to do, and it takes a long time. And you need to have a lab that is able to do it. It's usually quite expensive. So we have developed another test, which is called the ruler test, which is looking at the amount of additives that are in your oil. Combine these with the other tests that you see on the screen, and now you have a full oil analysis program that allows you to be more preventive instead of reactive with your oil. So a little bit of an example about the MPC. How it works. It stands for membrane patch colorimetry. It's a very quick, cost-effective way of assessing the oil's varnish potential. So you can see here on the right side, you can see a light-colored oil. On the left side, you can see a brown oil. So when we have an interactive workshop, I would ask the audience now, which oil do you think has the highest varnish potential? And of course, that is a trick question. Because when we run the MPC on the lighter colored oil, so this is an example of the MPC test. It gets pumped through the patch, which is here in the white area, and then we measure. And as you can see, surprise, the light-colored oil has a higher varnish potential than the dark-colored oil, right? So the MPC test is perfect for determining how much varnish is left on the patch. We rinse the patch with a polar solvent, which attaches the varnish to the patch, and then we can measure how much varnish potential is in the oil. So we do that via delta E. And the oil color is not related to the amount of varnish that is in the oil. So I think that's always very important for us to highlight, because so many people that we talk to in the market still look at oil color as a very important way of determining the oil health. But we have seen beautiful light brown, golden colored oils that are giving you very high varnish potential. So please don't look at oil color as a reliable method. As you can see here, in the left side, we have almost black oil that is having an MPC of 9.1, which is very good. On the right side, beautiful colored brown, a goldish colored oil, and surprise, an MPC of 37, which is critical. So the right oil needs to be changed. The left oil is actually perfectly good to go, judging by MPC. So please look at MPC and not just oil color to determine the varnish potential of the oil. With the MPC test, we can look at the color spectrum for degradation products that are related to soot, which would mean a temperature issue, EP additives that might have come out of solution or have been degraded, and sticky deposits that are generated as a result of oxidation. So it gives us a little bit of an indication of what is the problem in your turbine. If there's a lot of soot, a black patch, a high L level on the patch, we can look at thermal degradation, for example. If there's a lot of sticky oxidation-related deposits, we know we should probably look in the direction of oxidation. So the higher the MPC, the higher the varnish potential of your oil. So the MPC is a very handy test to look at the health of your oil. Now, when we combine this with ruler testing, that means we look at the antioxidants in your oil. We have two things that we look at. We look at phenolic antioxidants and aminic antioxidants. So typically, turbine oils have these two antioxidants. In hydraulic oils, you would also have ZDDPs, for example. If you have a zinc-free hydraulic, it would likely be aminics as well, or some phenols. But when you have a zinc-containing hydraulic, it's usually ZDDP as well. So we can measure that as well with the ruler. But this is for rotary equipment at the moment, what I'm showing you. So this would look at phenols and amines. What we want to do is, with the ruler test, we can determine how much percentage of these additives are left. So we want the oil to be always more to the left side. So more than 50% aminics left in the oil, or even more than 75% is usually even better. The MPC test, we can put these two alongside. We want the MPC to be below 15. So if both of these are okay, meaning the ruler test is more than 75%, the MPC is below 15, then we can say this oil is in good condition, and you are very unlikely to have varnish. In other words, you will have a good turbine oil life. The more it degrades, the less additives you have, the higher your MPC will be, the less life you will have in your turbine, and the more action you should take to look at it. So we also call this the turbine oil monitoring cheat sheet, because it's a very easy way of doing some relatively simple tests. The Rudon and MPC are not very complicated tests. You can do them relatively easily, and it will give you a very easy, predictive way of looking at your turbine oil. Now, in the field solutions, we can distinguish those in two main areas to deal with all of these issues that we have talked about today. Firstly, we can look at filtration. So we can do specialized filtration, which are based on electrophysical separation or ion exchange. So that's a chemisorption process. So it's like a chemical filtration process, which means it's able to absorb the varnish from your oil that normally passes through your depth media. So it's a special filtration system, not a normal depth media filter. And that is tailored to removing varnish from your system. Secondly, we can look at adding something to the oil, because the problem with varnish is solubility. It comes out of solution, but if we prevent that by adding the solubility enhancer to the oil, it never comes out of solution, so it doesn't become a problem. Firstly, let's look at the ESP system. The ESP is a ion exchange resin filter. So there's resin inside the canister that is in a kidney loop system in your oil, and this will interact with the varnish and it will absorb the varnish into the resin media bead, and this will clean up your oil. We use a specialized resin for varnish that we have done years of research on, and it is not interacting with your additive system or any other oil, and it is very efficient in removing varnish. And this is the way it actually works. We like to show this picture because you can see all three stages of the resin media bead on the picture on the right side. You can see a non-affected virgin bead that is not yet absorbing any varnish. In the middle, you can see a resin bead that is in the process of absorbing the varnish. And in the top of this picture, you can see the saturated resin bead. So that is already filled with varnish and it has done its job of absorbing. So the oil will pass through these resin media and the resin media will slowly absorb the varnish. These do get saturated at some point, so we need to change them every 6 months or 12 months, depending on how varnished your system is. But it's a very efficient way of cleaning up your oil and physically removing the varnish from your oil. But it is a slow process and it costs some energy because you need to do a kidney loop in your system, and that goes with a pump. So we have designed another method, which is also very suitable for hydraulic oils because they tend to have smaller volumes, and a kidney loop filtration system is not always practical on hydraulic oils or gearboxes. But also this is very suitable for turbine oils because this is a solubility enhancer. It's just one dosage into your oil that increases the solubility and prevents the varnish from filling into your system, and it will remove existing varnish as well. So it stands for decontamination. When you already have a varnish problem in your system, like the bearing issues that we have talked about earlier, this is a very effective way of decontaminating and reabsorbing the varnish in your system. Works very quickly. No negative impacts on the oil. We can also use it for deposit control. And that is really unique to this technology because deposit control means preventive. So we can put it in your oil and then we can let it run as long as your oil is alive. It has no negative impacts. It will prevent varnish from building up. That's what we call deposit control. So it's the only product that can be used reactive and preventive in the world at this moment. These are approved by OEMs, so they are completely risk-free to be used. How does it work? It's a very simple interaction with the varnished areas of your oil. So in this case, we have here a degraded molecule that we have showed all the way in the beginning that has been stressed and degraded and is producing free radicals. It will interact with decon. It will bond readily with oil degradation products, forming a new molecule which is no longer interactive. It does not produce any free radicals, so it is safe to be kept in the oil in this way. It produces another way of saying it. It's producing an oil-soluble molecule. That means it's no longer interactive. It's no longer forming agglomerates, which means varnish and bigger molecules. It's no longer doing any of that. So it's perfectly safe to keep this molecule inside your oil. Now, what happens if you already have a varnish layer on your bearing or your valve or wherever it is in the system? As long as there is oil flowing over it and you have decon in your system, decon will be able to interact with the varnish that is already on the metal. So it will be attracted to that varnish layer when the oil is flowing through it, and it will start to bond with the core of the agglomerated varnished molecule. And what happens then? It starts to generate dispersive forces by trying to attack that molecule. And then the molecule disperses and gets reabsorbed back into the oil. This allows decon to further interact with these molecules and form the same oil-soluble molecules that are then harmless, inert degradation products. And this is very safe to do until the varnish is completely gone. Now, you have to think a little bit about the actual amount of material that we are talking about, because sometimes people think, oh, this is scary. I'm redissolving it back into my system, then that will lead to problems in the future. But the amount of material that is causing the varnish issues is actually very low. That's what's making it so tricky as well. So it's causing a big issue, but typically the amount of varnish is when we redissolve it into the oil is not a problem at all. It can last for 10 years inside your turbine. Also, with hydraulics, we can do something similar. We have the option of cleaning the hydraulic with decon. It cleans the whole system, the valves, the servo valves, anything that has accumulated varnish, the heaters, the coolers, the injection molds, you can name it. We can clean that with decon, and then we can, for example, change the oil to a new oil that will then go into a clean system, which will last a lot longer. But also, when the additives are consumed in hydraulics, we can add something that is called decon AW or ZF, where we add solubility enhancer plus additives to your system, which then replenishes the oil's ability to combat oxidation, and it completely restores the oil's ability to function. So that is extending the life of the oil. So otherwise, you would have to discard the oil. Now we can save your oil and prevent a downtime on your system, and both your equipment and your oil will live longer because of this. So we can solve the varnish issue in turbine oils and rotary equipment, but also in hydraulic systems. Hydraulics are practically everywhere. There's so many applications for hydraulics. So the application of decon is actually pretty enormous. So let me just see, because I can see that miraculously I have some time left. So I'm going to show you a little bit more. Let me see how much time I have. Okay, so when we have an oil that has a high MPC, the actual amount of varnish is typically no more than 400 ppm. This would be a critical MPC of 40. So when we put a solubility enhancer in, like 3 to 5%, that would be 30,000 to 50,000 ppm to dissolve only this 400 ppm of material. So that is why this is such an effective method. It's a really unique way of redissolving the varnish in a safe and efficient way without any harm to your system. And what makes this product so unique is that we have done a lot of research and we have patented this molecule to be suitable for use in oil. So let's see. When we look at turbine oils, we also have the option of re-additizing. When the antioxidant levels of your turbine oil are getting low, there are 3 options that you can pursue as an end user. You can look at bleed and feed, the very common practice. You discharge a little bit of oil, you put a little bit of oil in, that keeps everything running nicely, right? But you are putting new oil into a contaminated system, an old system, or an old oil, I should say. Maybe your system is relatively new, but the oil is already a little bit degraded. And that, of course, that new oil will be degraded even faster if it's interacted with an old oil. So yes, it's an efficient way to prevent this shutdown, but over time, it's the most costly method that you can use to replenish your additives, because a lot of bleed and feed is always needed to maintain a similar oil health. And actually, you're doing an oil change. If you do 5 times 20% bleed and feed, it's an oil change. So if you do it every year, that means in 5 years' time, you have changed your oil. But the oil is constantly in a semi-contaminated state. So the oil companies love this because there's a lot of volume in bleed and feed. But for you as an end user, it's not the ideal solution. It's actually cheaper to do a full flush and oil change once every 5 years than do a yearly bleed and feed. But another option that we have is replenishing the antioxidants, replenishing the additives. This is a relatively new method, but we have proven this over the last 20 years, and it's a very efficient and cost-effective way that is now also approved by OEMs that you can use. So what does it mean? It means that when the additives go down, the MPC goes up, and the oil should be discarded, right? This is time for an oil change when your MPC here is at 59. But when we add Decon AO, we will reduce the MPC. We have Decon to dissolve the varnish, and we can increase the antioxidant level. So you can see here the RPVOT, it's going back to almost the level of the new oil. So by adding Decon AO, we revitalize this oil, and you can use it for another interval. If this oil has been in service and reached this point here in 8 years, and you revitalize it, we can assume that it can last another 8 years. So instead of changing your oil every 8 years, now it becomes 16 years. If it's 4 years, maybe it becomes 8 years, right? So you can easily double the lifespan of your oil. If you don't do anything with the oil, the MPC will continue to go up, and it will run into a lot of issues, of course. So let me just, sorry, I want to show another case study as well. In the world of hydraulics, we have also run a lot of case studies and tests. For example, here in excavators, they can fail due to thermal stress. And with Decon, we can provide a relatively simple solution to a complex issue. So we have seen that very common. You can see depleted ZDDP, dirt and debris in the system, wear metals in the system. So that makes it very susceptible to degradation. And you can see here a heavily varnished actuator in excavator system. And this led to a lot of issues within the system. So when we add Solvancer Decon into the system, this was verified by field trials. You can see that the oil was heavily varnished. And after treating it with Decon, it went back to below 25 MPC or below 30. So from a highly critical oil, we went back to a non-critical and usable oil. Over time, we could decrease this even further. And in a big excavator unit, this means that you can save a lot of oil. And also the system runs cleaner, lower temperature, more efficient as well. So we think this is a great case study to see as well. This is a beautiful example. This is from an ExxonMobil refinery where they had this bearing instability that we showed you in the beginning. They had the sawtooth pattern, varnish on the bearings, and this was a big issue for them because they were running at maximum production and they didn't have a shutdown planned. So if they would need to do an unplanned shutdown during this period, it would lose them millions of dollars of production. So they decided to try Decon, which was not in view at all at ExxonMobil because they didn't want to, put anything into the oil. They didn't want to try any additives. But in this case, they wanted to try because it was so urgent for them and so critical. So they said, okay, let's try Decon. We flew it over to their refinery by air freight because it was an urgent case. And lo and behold, here we go. Decon was added and immediately the bearing stabilized. The varnish was removed from the bearing, no more issues. Temperature spikes stopped. So the savings were estimated at least $1 million, but in reality, this was a huge refinery, a huge machine, huge compressor system. In reality, they probably saved multiple millions of dollars by not having to do a shutdown. So they could safely run, as you can see here, over 700 days. And I heard from the project manager of this project last week, actually, that today they're still running this equipment without any issues. So that's a total of 4 years without issues that Decon has been preventing the varnish in this bearing system. So huge savings for this customer. Here you can see a typical oil life extension, where the oil in a compressor system was always degrading after about 3 years of usage. They had to change the oil. And after they used our products, after they used Decon, that changed to a 7-year interval. So more than double the oil change interval. All right. So these are some of the main issues that we see with varnish and oil degradation, and also some of the solutions that we can provide to this. I think that gives me a nice wrap up for today's presentation. I'm happy I kept it well within 1 hour. So I hope it was very interesting for the audience, and I look forward to answering any questions that hopefully have been added to the chat. So thank you very much for your attention.
Okay, thank you, Lars, for this fruitful knowledge, I can say. So actually, there are a lot of questions on the chat box, but maybe I will divide it into like 3 main topic. First thing about the how to measure it, and then first thing, how to measure it, and maybe I directly ask you a question. Is it the varnish will be direct correlation into the ISO cleanliness and acid number? Maybe
Excellent.
That is the first question, Lars.
Excellent question. So the ISO cleanliness can be impacted by varnish. Let me see if I have an example with me in this presentation. It's not with me here in this presentation, but very often we see the small particles, the below 4 micron, can increase due to varnish. So the ISO particle counter will pick up the small varnish particles. So we have a lot of cases where people have a particle issue and they put in filtration and it's not helping. That's because these agglomerates, they will pass through the filter membrane. Even if you put a 1 micron filter there, you will still have a high particle count of 4 micron. So that's sometimes very puzzling. And then when we put in Decon or ESP filtration system, these agglomerates get dissolved or removed from the oil, and then the ISO particle count will go down as well. With acid number, this is usually, it can be other things, but usually it's a result of oxidation. So that means probably your additives have already been depleted. That leads to an increase of acid number. But of course, that will also produce varnish and deposits, right? So there is not a direct correlation, but it is an important indicator that there is something wrong with your oil. And actually, when the acid number goes up, that's already considered to be an advanced degradation, especially, it depends a bit on the application, but in a turbine oil, by the time your acid number goes up, it means your additives are probably already depleted, leading to oxidation, polymerization, varnish. So that's usually a big symptom in the oil analysis study. It could also mean you have a gas leak, that there is some gas ingression to the oil that is directly producing acids, but that's a little bit more rare. 9 out of 10 cases, it's oxidation, which is related to varnish, but it's not a direct correlation. So we need to look at all of these items together.
Okay, understand. And then related with the customer experience on the chat box. First thing, there are cooling tower gearbox, and he found varnish on the inside the gearbox. And the question is, how possible the varnish issue into the cooling tower gearbox, and then related with also equipment, but other equipment, but he doesn't mention it about how to tackle varnish when the lubricant contact with the cyclopentane.
Okay. Yeah, that's a reactive substance, right? So what kind of lubricant is that? I would want to ask, but so that's important. We would need to look at it a little bit more in detail. But the origin of the varnish on the gearbox can be many things, right? It's the thermal degradation of the oil that is degrading the lubricant that would create the varnish layer on gearboxes as well. It's very common to see. When it goes to interacting with pentane, I would want to look a little bit more in depth, and maybe we can discuss it separately.
Okay. And another equipment is electrohydraulic control oil, electrohydraulic control fluid.
Yes.
If the varnish happen visually or based on the varnish potential, can the varnish be clean or removed?
Yeah, so usually what we would advise you to do, I'm guessing that this is a question that's related to a shutdown where you would already see the varnish. So in that case, it is probably quite difficult. You would need to do a manual cleaning and use certain amounts of detergents. However, the best way is to use a solubility enhancer before you shut down your system. And we can share with you some OEM recommendations as well. So for example, OEMs of turbines, they recommend now to use solubility enhancers before a shutdown of the oil, because that would dissolve all the varnish, so that when you shut down, you don't have to do a manual cleaning, and you can absorb the varnish back into the oil before you do the shutdown.
Okay. And there are a lot of customer experience and with the different equipment type, Lars.
Yes.
So another thing, he have I think it's a gas engine, Wärtsilä, 10 megawatt, and the fuel is operate using 40% biodiesel. And another question in the chat box, also using 50% biodiesel. And related the biodiesel in engine oil, is it possible to have a impact of lube oil degradation or maybe the varnish issue in the engine oil?
Yes, absolutely. So biodiesel has a higher amount of impurities and is more susceptible to oxidation. So very often acidity is a problem with these kind of oils. So you will have rising AN number, and the diesel oil will have a additive package that is able to neutralize this. But when there's more acidity forming, then this will become an issue. So we see a lot of these jelly types, agglomerated varnish on the crankcase. In the oil filter as well, you can get these jelly deposits that are forming due to acidic oxidation byproducts. We have run tests with Decon for this. Unfortunately, because of the additive package in the engine oil, there's a lot of dispersant additives in engine oil, and that is degrading the effectiveness of Decon. So we cannot help with engine oils, unfortunately. We are limited to industrial oils, but we are very aware of this issue. And yes, we have seen this before. That is due to the acidity and the oxidation of the fuel interacting with the oil, and that can lead to these kind of issues. Yeah.
I see. And also for the previous electrohydraulic control oil, cannot also using a Decon or solubility enhancer.
No, that's correct. Yeah, if it's an EHC fluid, so a phosphate ester fire resistant fluid, that is not compatible with Decon, then we can use ESP filtration to clean the system. That's right. But if it's a mineral oil, because sometimes you also have mineral hydraulic fluids in these applications, if it's not a fire resistant fluid, then we can use solubility enhancers. So it depends on the type of fluid.
I see, nice. Okay, so we can continue about how to mitigate it. Yeah, I believe you already share about VRU, varnish removal unit, or the solubility enhancer. Maybe you can share again, because a lot of question how to manage the varnish issue, and also one question about if the antioxidant is going down, going low, how to manage it.
Okay, so sorry, can you repeat the first part?
How to mitigate varnish issue, yeah.
Okay. You want me to share again, right?
Yes, about the
All right.
VRU and the solubility enhancer.
Okay, yeah. All right, so let's see.
Yeah, that one.
So when you have determined there is a varnish issue, you can go two ways. You can choose to apply an ESP filtration method, so electrophysical separation, which you can see here depicted. That can be an inline filtration system, which would require a shutdown and some engineering to be done to install this. You can also go for a kidney loop filtration system called Vita ESP. Another very good solution that we have now is solubility enhancement. So varnish is coming out of solution into your system. If we prevent that from happening by adding something to your oil, that would be even better maybe for your application. It depends on how you want to treat it. So solubility enhancers are very efficient as well. These are the two main methods that we can use to mitigate varnish.
Okay.
You want me to explain more detail? Let me know how the
Yeah, specifically for the antioxidant, yeah, because there are questions about phenolic and aminic, and he mentioned about the aminic drop is more faster than phenolic drop. Is it quite common, or it's like a specific case? Yeah.
Yes. No. Normally we have we see the. To use another slide deck. Sorry, that's a bit more info on this. Normally we see the phenolics drop first. That's for sure. Because the phenolics are actually in place to revitalize the aminic antioxidants. So when the aminic goes first, that can have various issues. That could be a very intense hotspot in the oil that is quickly degrading the aminics. It could be some reaction that is happening in the oil that is directly reacting with the aminic antioxidants. So we would need to do a bit of root cause analysis on the oil, looking at, for example, if there are varnish deposits in your system. We could do deposit characterization. We can do an SEM EDX on it to determine whether it's an organic or a wear metal that is impacting forming the deposits. What is the substance? The FTIR analysis could also be insightful there to look at the composition of the deposits. And then we can start to determine whether that is something that interacts with your aminic to find the root cause. But normally it's the phenolic that goes first. So it's an indication that there's something out of the ordinary happening in your oil.
Yep. So it can be from the hotspot or other.
Yeah, a hotspot or something interacting with the oil.
Yep. And then on the economic wise, yeah. So how do you justify the cost benefit of full system flushing or periodic oil change versus investing in decon treatment, Lars?
Yeah. Very good. Okay. So we have done a lot of research on that. So here you can see an example of a customer that has done 2 times a dosage of decon AO instead of the oil change. So one in 2013, one in 2023. And this oil has been in service for a total of 18 years now. And when we compare that, so we have something that is called ROI, a return on investment calculator. So this case was this is per gallon, so don't get scared by this is a US measurement. So we can see here the oil age, the anticipated remaining life, the price of the oil, the disposal cost, flushing cost will be taken into account. And in this case, there were no known problems with the oil, so there were no direct, let's say, yearly bearing replacement or valve issues that we could solve. So that is actually diminishing the ROI. But still, you can see that we have saved this customer $350,000 on this one system by preventing the oil change. So usually, if you count the price of new oil plus flushing, manpower, and the flushing chemicals, right? And sometimes the displacement oil needs to be counted as well. Combining that together is already more costly than putting in decon AO or decon into your system, right? Now, if we also count the shutdown time, that's not counted here, for example, because if you want to change an oil, you need probably at least a week shutdown. When you add something to the oil, like decon or decon AO, you do not need to do a shutdown. So depending on the cost of your production and the value of your production, that can be maybe $50,000, can be $100,000, but some plants that are making high value products, it can be $1 million. With a power plant, the savings of preventing a shutdown can be enormous, right? So that's also something you need to take into account. So usually we have a very positive ROI calculation. But we can do this together with the customer. We can fill it in and help you do the ROI calculation. Okay.
So from the case study in FLUITEC, there are life extension and cost saving, compared the unplanned shutdown. And
Yes,
then I will next question about back to the varnish issue, So after the varnish saturated and become sludge, is it possible the bearing become the bearing and the oil become more dirty and deposit on the bearing?
Yes, absolutely. So once the oil is saturated, that is exactly the moment when the varnish will start to come out of solution. And it can deposit in the bearing, in the oil tank, in the valves, and you will see it during manual inspection as well.
Okay.
And that is why when we use a solubility enhancer, we increase the solubility of the oil. So we actually increase the saturation point of the oil to contain the varnish.
Okay, I go to next question about when varnish repeat or appear after cleaning, maybe cleaning the tank, for example. How can we determine the root cause of that varnish?
Yeah. So
or the machine operating environment. If a machine is still running normally despite having varnish contamination, how should maintenance team decide when intervention is necessary rather than waiting until the varnish goes on actual failure?
Yeah, correct. So it's always about the oil analysis test and operational conditions. These two go together. So first of all, I would say test for NPC and ruler. Those are the main indicators of of looking at how much life is left in your oil. When they are approaching the critical stage, or when, for example, your NPC is going critical, don't wait too long, because also the OEMs are very clear. Once your NPC is going up, that means your oil is producing varnish, or is likely to produce varnish. So that is the moment where you actually want to act immediately. You can also look at the ruler test, the amount of antioxidants. When that goes to about 50%, even when your MPC is still low, you know that this oil is starting to be more sensitive to oxidation. So you want to act at that moment as well. So these are the two parameters on the oil analysis that we can look at, right? Operationally, you can look at, for example, bearing temperatures. Remember the sawtooth pattern that we saw? When this is occurring, also act immediately, because this will only get bigger, and you already know there's a varnish issue in your bearing when you have the sawtooth pattern. So let's do something and act immediately. Of course, it's a combination of, when do I have my shutdown? What are the risks? What are the financial consequences of doing something versus waiting maybe for the next shutdown? Do I use decon? Do I use ESP? Do I clean my system and go for an oil change, right? So you do have many options as an operator, but it's really starting with having the right data, the preventive oil analysis test, operating conditions, and then talking to specialists like FLUITEC to help you with determining the right time to act, or talk to lubrication specialists or the laboratories, for example. So these are some of the things that you can do as an end user to help with your decision-making process. But at the end of the day, it's really case by case. It depends on your oil condition, your operating condition, the volume of oil, the type of oil. All of these things need to be taken into consideration. And we'll be happy to
Got it,
help with that, of
Lars.
course. Yeah.
Yeah. Okay. Because we have a limited time, so if customer want to ask about the lubricant or consultancy, anything about their equipment, so customer can contact you directly or with
Definitely.
with us, Tiara,
Yes.
yeah.
Both, yeah, absolutely. It's fine. We'd be happy to answer any questions, and I hope we can get the contacts of the people that asked the questions, so we can look into it a little bit more detail, and maybe share some case studies with you, and contact you proactively. If the attendees are okay with that, then we can keep sharing related to the questions that they asked.
Okay, great.
All right.
So thank you very much, Lars,
Thank
for
you.
your sharing on this time. So I will continue using bahasa, ya.
Okay, thank you very much, everyone.
Oke, ya terima kasih Bapak dan Ibu untuk pertanyaan dan diskusinya di siang hari ini. Jadi untuk jika ada pertanyaan tambahan bisa dikirimkan ke kami, dan bisa diisi juga form feedback ya nantinya ya. Terus berikutnya juga akan ada giveaway e-wallet melalui spin wheel. Selanjutnya juga akan ada event training nih ceritanya. Training itu akan dilaksanakan di bulan September, di tanggal 9 sampai dengan 11 September, terkait dengan generator testing diagnostik. Ya, nanti di training tersebut akan bagaimana mendiagnosa stator dan rotor melalui pengujian-pengujiannya. Terus kemudian ada advance partial discharge pattern analysis dan noise discrimination, dan juga nggak ketinggalan ya ada case study pada training tersebut. Ya, ini merupakan trainernya nanti, dan sifatnya offline training ya, yang akan dilakukan di Tiara Competency Center di Yogyakarta. Oke, nanti bisa menghubungi Miss Tiara juga. Selanjutnya masuk ke spin wheel giveaway. Untuk spin wheel e-wallet nanti bisa melalui platform-platform yang ada. Kita lihat kira-kira siapa nih penanya yang akan mendapatkan e-wallet. Banyak nih nama-namanya. Pak Merah, Pak Biru. Enggak. Jadi untuk pemenang pertama kepada Bapak Juventus Wibowo. Selamat kepada Bapak Juventus. Nantinya akan dihubungi Miss Tiara ya terkait dengan e-walletnya. Selanjutnya untuk pemenang kedua. Pemenang kedua didapatkan pada Pak siapa nih? Pak Robi Febrian. Pak Robi Febrian sama akan mendapatkan e-wallet dan dihubungi oleh Miss Tiara ya. Dari kami ada 2 lagi giveaway, tetapi syaratnya harus mengisi dulu form feedback. Kemudian nanti pun untuk Bapak Ibu yang sudah mengisi form feedback akan diberikan juga ya link untuk materi pada hari ini dan juga e-certificate ya. Baik, kalau gitu saya ucapkan terima kasih banyak Bapak Ibu untuk partisipasinya. Sekali lagi jika ada pertanyaan lanjutan bisa menghubungi kami dan jangan lupa untuk bisa mengikuti training ya di bulan September nanti. Saya rasa bisa dicukupkan. Terima kasih banyak. Wassalamualaikum warahmatullahi wabarakatuh. Sampai jumpa lagi.